Hello everyone, this is Dr. Salam Temitope again. Welcome to the last segment of the identification of microbes hands-on training. Now, this last video will be showing us hands-on how to actually do our phylogenetic analysis using our previously aligned cluster W sequences on Mega. So the next thing now to do is to go back to our Mega. If you've closed it, kindly double click and open it, or right click and open it. For me, I've opened it now. I maximize it. Now, the next thing is to go to the tab of phylogeny, click on it and select the neighbor construct / test of neighbor joining tree. As I previously said, as soon as you click on it, it's going to open this window of choose a data file to analyze. And like I said earlier, you need to make sure that it's on your desktop, as it is in desktop here, because that is where the file is saved. So at the file type area here, where you have Mega file, we need to change to all files, because we want all the files on our desktop to be shown so that we can select our SF4 alignment. So you just need to scroll down. My desktop is aligned in alphabetical order, so I've seen my SF4 alignment file, and then I've clicked on it, and then just say open. The moment you click open, it redirects you to the window for analysis preference as shown. Now, like I said earlier, you need to pay attention to the number of bootstrap replication, as I explained. Now it's 1000 as my default. If it is not 1000 as your default, all you need to do is click on it like I've done, and then you increase it as appropriate. So it increases by hundreds. So whatever it is, just click appropriate and set it to 1000. Okay, so and then the next thing is to just click compute. Now the alignment is the phylogenetic tree is being plotted, and then it is just ready for further analysis, as we discussed earlier. So now the tree is plotted again. Then we can see that our organism is actually close, like I said earlier, to clustered with the Bacillus megatherium group, and then it's a strain. These are the closest relative for which it shares homology, and this is used in estimating evolutionary distance. So now, to copy this image for further use, I said you will click on the image tab and select copy to clipboard. Now, when you select copy to clipboard, you've copied this image from this Tree Explorer window, and then we can easily go to a PowerPoint presentation. You can open a new PowerPoint presentation. For example, if I'm doing a new PowerPoint presentation, probably I need this for a presentation, so I can just go in there and then paste, and then this is my phylogenetic tree. So if it is in the case of a Microsoft Word document, probably I'm preparing a manuscript, or I'm preparing a report, and I need to use this phylogenetic tree. I've loaded my Microsoft Word, and then all I need to do here is paste appropriately, and you can see the phylogenetic tree that is pasted there as well. So we go back to our Mega, and then there's also the option to save. What if I want to save this? I want to make reference to it for my further work. Of course, you don't have to go through this over and over again. And so, like I said earlier, all you need to do is come to File, and then you click on Save Current Session, and then still on the desktop, because I actually prefer to save on the desktop. It's easier for me to locate my documents, so I save with SF4 tree, and then I save it on my desktop. So the tree is saved on my desktop, so I can make reference to it when I'm doing my further work. And like I said earlier, this process is pretty much the same, starting from sequence alignment all the way to phylogenetic analysis for for all microbes except for modes where you sequence the ITS1 to ITS4. I do hope that with this short demonstration, which I expect that you would follow and repeat, I do hope that with this short demonstration, I've been able to show us the process of identification of microbes, starting all the way from the wet lab to the dry lab procedure, especially demonstrating with bacteria, and then we've successfully identified SF4 as Bacillus, as a strain of Bacillus megaterium. Thank you very much for your time, and I do hope that we can have the opportunity to visit these slides and practice in our own private time. Thank you very much again for the opportunity.